Good morning, everyone. Welcome to all of our new and regular attendees to Tabor Institute's webinar, Monte Carlo Schedule and Cost Risk Demystified. For those of you who are attending for the first time, my name is Michael Trumper. I'm one of the principals here at Tabor Institute and have been in the area of the project risk analysis and management and software development for almost 20 years. The webinar will include both slides and a quick live demonstration and is being recorded and will be available for viewing on our website within 48 hours. Before we start, I would just like to go over some housekeeping and how you can participate in the webinar. You should see a pane at the top right corner of your screen, which should allow you to select your audio and also interact during the webinar. If you haven't done so, I recommend using the computer and mic and speakers as the audio quality tends to be better. Feel free to use the questions panes to ask questions during the webinar. If you have technical issues with the broadcast, you can ask in the questions pane, and we will address them as best we can. Otherwise, all of the other questions will be answered at the end of the webinar in the order that they came in a Q&A session, and we can keep that going for as long as required. I thought it would be appropriate to start this with a quote from Albert Einstein, as it captures points to the universal presence of uncertainty in projects. So, this is what we'll be looking at today. What are Monte Carlo simulations and how can it improve your project forecast? We'll get into the weeds in this and what are statistical distributions and how they can be used to model risk and uncertainties. To run a Monte Carlo simulation with risks and uncertainties, and what are the results of a Monte Carlo simulation and how they can be used to optimize your project. So improving project forecasts. So the first thing that will come out of it, I just wanted to cover this earlier, is that we are able to identify and manage critical risks and activities. We can create realistic or credible project plans. And we can account for natural variances in execution. And from that, we can calculate risk-appropriate schedule margin and contingency reserve. So often get asked the question, why Monte Carlo simulation? Why not just critical path? Or we also see PERT, which is the program evaluation review technique, which also uses 3-point estimates. Which uses a weighted average. Well, Monte Carlo simulation is the only process or methodology that we have right now that can account for two effects that we see in the large complex projects. These large complex projects will have multiple instances of parallel activities that link to a common successor. When we add risks or uncertainties, what can occur is multiple critical paths can occur during a simulation. Or you may have heard of this, or you may have heard of them as near critical paths. Critical path methodology that cannot account for this effect. So it only does a single path. It's not taking into account risk and uncertainties, and will always give you a single critical path. And these tasks that are on or near the critical path are referred to as crucial tasks. So these are the tasks that we need to focus on during our project execution. Second, in large complex projects with many activities, something interesting happens due to the cumulative impact of right-skewed distributions. It's called the portfolio effect. The range of uncertainties, and I'm not sure if the image here, what occurs during Monte Carlo simulation, actually the range of uncertainty tends to decrease. So you can see that in the second one, it's actually compressing. So we have less variance, but what happens is that that whole distribution from the results shifts to the right. And this is sort of a mathematical phenomenon, but it does occur. And between the two of these, the estimate is that they can add up to 20% to the duration of your project. And currently we don't have any other tools other than Monte Carlo simulation that's going to account for these two effects that you will have in your project schedule. So first I want to, when we look at this, we call it risk. You might have heard it called risk or uncertainties, and often they're go on together as the same thing. Risk is uncertainty. And while we know that we're trying to measure risk, the way that we refer to it is often misunderstood. Risk in projects come from two sources: risk events, or you might have heard of them as risk drivers, and uncertainties. Both types of risks should be added to the risk model to increase the validity of the analysis. The difference between them, one is the manageable risk, and you can see they have a probability of occurring, so they don't occur all the time during when you run a Monte Carlo simulation. In each iteration, that risk is going to be occurring probabilistically, off or on, sort of binary, depending on the probability. The other side of that is that they are reducible. Because it has a probability, these are the risks that can be managed. And that's why you're going to, when we run a Monte Carlo sim, we want to rank these risks which have the biggest impact, because those are the ones we're going to identify that need to be managed first. And those might be considered critical risks. The rest of the risks that we are unable to eliminate either by avoiding, transferring, or mitigating is considered residual risk, and it's combined with the unmanageable risk at the bottom. So the unmanageable risk, uncertainties, you might have heard of as aleatory risk. It's natural variance caused by the randomness in all processes. And we characterize it, or we model it using statistical distribution that capture the most likely and boundary estimates, low and high. And again, one of the important things about this, they're irreducible. What we're saying is we can't do anything about it, so we need to account for it. And both of these risks represent ranges of possible outcomes that can be modeled using statistical distributions. So what are statistical distributions? Well, this is a little picture. You can see if you've got a copy of our software. I've just pulled this directly. This is a statistical distribution for a task that has a most likely estimate of 5 days and a low of 3 and a high of 8. And we can see how that's been defined in here. The graph is showing the probability that certain durations can occur. So as we look over, we see the probability goes up to Y and the duration go up the X. And we can see that at the 3 days, there's almost a 0% chance that it can occur. At 5 days, we have about a 33% chance occurring. This is pretty standard when we look at triangular distributions and schedules. And then as you go down, and what happens is during a Monte Carlo simulation, random numbers being picked based on the probability. So if we run this 100 times, the duration of 5 days will be picked about 34 times. Your duration of 4 days will get picked probably about 13 times. So this is one of the things. So we're modeling this, and this is called a probability distribution function. One of the important things we can also note is that our most likely estimate, and this is really something important in schedule analysis, is that the most likely is to the left of the mean. Most of the probability we can see here is to the right of the most likely. And that means our average or our mean is going to end up somewhere around, I don't have it put on here, but it will end up somewhere around here. And that's really important issue around when we think of most likely versus average, when we're trying to understand activities that are probabilistic and uncertain. And if you ask why is it not 2 days, 3 days, and 7 days, typically we have optimism bias tends to take over. Mathematically, we can only complete an activity in a certain amount of time. So we can't complete an activity in 0 days. So that's not possible. But on the other side, on the tail here, an activity can go on and realistic, become infinitive. It never gets done because of something occurs. So we always tend to have a longer tail. It tends to be right skewed when we do schedule risk analysis. And I would say if you see a schedule that has a lot of equilateral triangles or distributions on there, they're probably not going to be very realistic. So here's our distribution types. Now, this is just an example of them. There's several common ones. Our application has 13 that go in. The guidance is that we get, most industries, is to use the triangular as a default for your distribution, unless you have good historical data that models a different type of distribution type, like normal or log normal or uniform. And you can use uniform if you don't have any idea about when it's what the impact will be, what the most likely is opposed to the boundaries. But again, we want to sort of use, and we have tested this quite a bit and run many simulations. And really, because we're modeling at 1 or 2, Steve, we were sort of looking at 1 or 2 standard deviations, which is sort of a measure of uncertainty. What we find is that at the boundary levels, you'll see some differences between the distributions, but for the most part, triangular will give you the good enough answer that you need to be able to understand the implications of risk and uncertainty on your schedule. So what is Monte Carlo analysis? So in a Monte Carlo simulation, every activity is assigned a statistical distribution. So if we looked at in both of these images, you can have different tasks, they can have different types of distributions. And during each iteration of a simulation, a calculation engine pulls a random value from each distribution as inputs for the schedule and calculates duration, starts time, finish times, variable work, etc. A simulation can include thousands of randomly generated schedules generated using these random values, and then calculates the risk-adjusted values for the entire project. Which are also statistical distributions. So this is a simple visualization of how a Monte Carlo simulation would occur. So we have a random number generation. It generates a value. Here we're just looking at how triangular distribution, random numbers are generated. So in this case, in this iteration, it pulls from here and it's going to pull 1 days, 3.41 days. And then it puts it into the schedule and runs the schedule using this value. And it's doing that for every single activity in the schedule. And again, we repeat many times. How many times? That's really depending how we set up our simulation. Generally, minimum of about 1,000, but we can run them higher or lower. So this is one example that we've used many times in the past. You might have seen it on some of our presentations on our website. So if we're going to, this is an example, how do we come up with these distributions? So this would be like a real life example. If you wanted to find historical data about how you should model performing a certain activity, you could do an example like this. So you're going to go in, and in this one, we're going to say we're installing this thing 20 times, and we're going to record the duration each time. And this is what you might get. And we can see that we can finish the installation for the 2 times in less than half an hour or less, 10 times in an hour or less, 5 times in an hour and a half or less. It's between there, but that really it's saying 5 times we're going to be able to do it in that interval, and the last interval between an hour and a half and 2 hours, we get this, and we get these values on probabilities for those. And so when we get these values, we can actually represent them as statistical distributions in form of what we call a histogram. So that's that probability distribution that you will see in some of the charts, and or a cumulative probability plot. So the histogram is just showing us that we can see this. Here's that 2 times we finished it between 0 and half an hour, and 10 times we were able to finish it, and we can see 10 and down, and then we can also develop this cumulative probability. Cumulative probability is a very powerful tool for understanding what confidence levels that we have. So for us, I know that 80% of the time I have my confidence level is that at 80% of the time I'll be able to finish this activity in an hour and a half. Now I might be shooting when I look at it, I might be going for an hour. I want to be able to, I want to do as quickly and efficiently as possible. But if I wanted to have a bit of enough margin that if I had another activity I had to plan, and maybe I had to, was coordinating with someone else, I would add that additional half hour to that to say, okay, we'll start here, and I've got a fairly high confidence that I'll be able to go up and start this next activity after an hour and a half. If I wanted to be completely confident, take no risk at all in it, I could say, okay, meet me in 2 hours. We'll start in 2 hours again, but then everything else is going to get pushed down the path, and things will take longer if you have to schedule it the next activity 2 hours later. So, and that's part of when you think about risk tolerance. So, preparing your schedule for Monte Carlo analysis. So we just talked about there's 2 different types of risk. We're using statistical distributions. So we're going to go and say just a sort of a practical, quick guide about how you want to set up your schedule for Monte Carlo analysis. So the first step is we're going to, it's called doing a schedule quality. Then we're going to assign risks and uncertainties to it. We will then set our calculation parameters, and then we can run the simulation and see the results of that. So schedule quality. So the Monte Carlo simulation requires that you run hundreds of varying models of your schedules, which means your schedule must update automatically whenever dates or durations change due to risk or uncertainty. If your schedule is not optimized so that it updates automatically, the results of the simulation will often be overly optimistic and I would consider invalid. The most important items are dangling activities. During a simulation, if you modify the dates or duration of activities that are missing predecessors or successors, with some exceptions, these changes will not be reflected in the results of the simulation because they're just not pushing or pulling your activities. Hard constraints, we want to minimize them. Again, these are constraints such as must start on or must finish by, block this updating of the schedule. So along with dangling, which don't push or pull, if you have these hard constraints, they will also stop the schedule from updating properly due to risk uncertainties or risk events occurring. So normally, as much as possible, we'd like to change all of these to start as soon as possible. In our software, you can see that we have these red outlines, and that's one of the visual cues that we have, is that you've got some hard constraints. It's also, you'll see them if you have actuals, because if it's actuals, then it's not really a constraint. It means that's when it occurred. And what we would do is we run this when we bring in the schedule, is we're going to run a schedule diagnostics. And within our software, we have a standard 14-point DCMA check that will allow you to quickly identify issues and address them as appropriate. For us, it's really about hard constraints, relationship types, and there could be a missing logic, would be like dangling activities. We want to run this diagnostics to make sure that when you run your schedule, you're going to have a valid output. So the next step, and this can be when we're going to assign risks. Risks can be global or local. Global risks are systemic risks. We don't see them too often. A lot of times now we're going to model global systemic risks like weather or something using a probabilistic or weather calendar. Local risks are risks that are assigned either to activities or resources. And risk can be assigned to multiple activities and or multiple resources. So it has a chance, which is probability between 0 and 100%. It has an outcome type. So the outcome is the impact. Is it duration? Is it cost? Or it could be, you can look at non-schedule categories. And then it's what kind, relative or fixed. With schedule, you can also have cancel, restart task, execute response plan. Those are some other outcomes that you can have. Relative, we use, generally we're going to use if the risk is assigned to multiple activities, so it's seen as a % increase or a % decrease. Fixed, often going to use that for on a single activity, and we have a good idea about what the impact is in terms of days or weeks or months of that risk. And if it's on a single one, that's a guidance that we give. Fixed cost, if you have a fixed cost risk, you could also do that. So when you have cost, if you've loaded cost into fixed cost in the system, you can also add a fixed cost risk occurring. And then again, that can be modeled as a single cost or impact or a range of costs. When we're doing this, really the best source is always going to be historical data. If you have risk registers, if you have a record of all your risk registers, what happened during your project, did they occur? Did they not occur? Did the plans that we used, did they work? Subject matter experts and or brainstorming or other identification and assessment methodologies. So that's what we're going to do. Again, we always recommend it, if you have a historical risk registers in your company, that's your best source. And then and then you can look at that as being the baseline, and then look at what's new or unique about the specific project to add or modify those risk registers, risks that are in that risk register. So adding uncertainties. Again, we talked about its inherent variability in all project activities. All other than milestones, every activity in the schedule, not just the ones on the critical path, but every single one needs to have uncertainty associated with, because every activity is going to have some level of uncertainty. Now you can characterize that in different ways. We have something called risk bands, where you can characterize it and calculate it based on what we consider low, medium, or high risk. We actually have up to 10 bands, but you can simplify that. But it's modeled using 3 and that probability distribution function. Again, what we can see right here is a statistical distribution. It's triangular with a most likely of 2 and a low of 1.4 and a high of 4 days. And you can see again, where do you get this data? Sometimes we call it reference classes. There's lots of data where many activities have been, similar activities occurred over time, and you can see how long it will take, perhaps how much it will cost. Historical, and these are all based on historical data for similar projects and technologies. And then, once you've done that, you can always then rely and lean on project team members or subject matter experts to modify those to meet whatever unique or specific about your project. So then we'll look at calculation settings, and we'll show this in the demo quickly. We have something called instant Monte Carlo. This allows you to run an instant simulations when you make changes to your model. So if you have and I typically, if I have a small schedule that's only a couple hundred activities and not a lot of risk in it, I'll put this probabilistic. And what the application does behind the scenes, it's modeling what computer resources are available, how many activities, how many risks, and then it runs an algorithm that says it's going to take me the computer this long to run these simulations. And if it can run it under a second, it will run it. If it can't, it won't. And then you'll have to execute it. The problem with that is that when you're right at that edge, it can be, and if you're doing a lot of changes to your project schedule, anything, it can become very jumpy. So you'll make one change to a date, change it from, duration, your high duration from 5 to 6, let's say, and then it'll go, oh, I got to resimulate. So I'll run a simulation. It might be a second, it might be a second and a half, who knows? So you can turn that on on quick small ones if you're doing it. Typically, I'm gonna have it on deterministic. That means I'm going to have to actually push a button to make that simulation run. Convergence monitoring, a number of iterations. Convergence monitoring is useful if you're running you're doing a lot of what-if analysis, and you just want to run until you get a statistically correct simulation. And so what that means is that, and it's defined by these 2 inputs on here. When your mean and standard deviation, they don't change by over 0.15. So behind the scenes, it's always calculating this over a certain amount of, I should say iterations, but it's 20. This is the default settings. Again, if you just want to you want to quickly get a good enough answer, rather than, let's say you want to run one that's at the final, you have to put out reports and you want to really, and you have high probability or low probability, high impact risk, I would always I don't have convergence on. but it's something to be aware of. Our maximum will run up to 10,000 iterations. Finally, setting the low and high results. Sometimes people think that's what I'm putting in, but that's not it's the outputs. So when we look at the reports or the charts and you see markers for high or data that says high results or low results, calculated results, this is what we're looking at. We're looking at, we can set this here. Default is P10, P90. I always set this, and this value right here should be set at an organization level. That's your level that we want to use as a confidence level that we're going to set up cost contingency and schedule margin. So that would be your risk adjusted. So when you go and look at that, and we'll show this in the activities or in the application, we want to set where we want to be able to generate margin and contingency, and we're going to use this setting right here to show that in the results of the analysis. And you can see you can calculate critical path. Unless you need to run and generate what's called critical indexes, which says how often a activity is going to land on a critical path during the simulation, I would turn it off because it doubles the amount of calculations you're doing, because you're doing a forward pass and then a backward path with critical path. So once we run that, these are the results of the analysis that we get. We'll take a look at this. We get cumulative probability, and we can look at this right here. Here's our distributions. This one has risk events, and we have our P80. The difference between our original here is generally this is at project level, but it can be pulled out at WBS item levels, milestones, however you want to develop that. But that's what we're setting that up. A risk-adjusted schedule. This is in our result. It's just showing us how the activities are each activity is being affected by risk and uncertainty that's been assigned to them. Critical risks, one of the most important things we do. By default, in the application, when we run, we have risks assigned to the schedule, it will automatically rank your risk based on the score. It's always going to be prioritizing. That's the most important thing to think of, is that I'm less concerned about the risks, where they sit on a risk matrix or anything. I want to just know the priority, which risks are the most important ones to be managed in the schedule. The other major output that we get from there, sensitivity analysis. Sensitivity analysis is telling us which risks, and the critical risk is also, as a result, takes into account the sensitivity analysis is based on correlation coefficients, which activities and which risks are going to have the most impact on your schedule. And if we look at the sensitivity and crucial tasks, we're actually taking the sensitivity analysis and putting it on a Gantt chart. We can see which activities are considered crucial in a schedule. So this is a really useful visualization. And then you can also get cash cost analysis and probabilistic cash flow. That shows us the spend, expected spend that we're going to have due to risk and uncertainty delays. If we have delays, we're going to actually be spending money, end up spending money later, and that can be an issue when you have budgeted items that money needs to be spent at over specific times. So, sorry, my voice is dying on me here. I'm just going to change what we're showing. If I can find out. There it is. And I'm just going to quickly go through a couple of things. So this is the portfolio effect I mentioned earlier. And what we can see here is we have 10 activities with 50 days outcome. They all have 5 days, 10. So we get 5 days, but they do have some uncertainties associated with them. And then when we run that, if we want to look at the project summary, what occurs is because of that right skewed distributions, we now see that, and this is always a bit, we can now see that our most likely has shifted over to here. And we only actually have, we can go all the way to here and just drag that over and it'll tell. We have about a 1% chance. That seems a bit low because often it'll be about 13% chance. But that is just because of having all of these statistical distributions, right skewed distributions for duration in a precedent network. And this is what happens. And what we're starting to see is that if you want to look up the portfolio effect in schedules, what happens is that the P50 actually tightens and moves closer towards the mean. And that sort of shifts everything. You actually get a little bit of a less variance, but it also is, so it gets tighter. But it's also shifting to the right. The other thing that we have is the parallel activities. Hopefully this is going to open up without too much. And here we have just a bunch of activities that are all linked, start. We have the one up here and it's 5 days and the rest of them are 4 days. And we have some uncertainties on them, which we could have. I don't have any risks. And when we run the calculation on that, and we go to, and this is that risk adjusted schedule that we saw, we can now see that what was now 5 days, we can see now that we have 6 days that it would most likely occur. So we've added 1 day, which is around, it's about 20%. So this is probably a little bit unrealistic because of what's happening is because we have this activity that was on the critical path would have been on the critical path, but this one with its uncertainties is jumping onto the critical path. This one can jump onto the critical path. We can see from these tails on here. Those are our high results. So those are the two major reasons in which that Monte Carlo simulations, the two questions that we can answer. What is going to be the effect of all these parallel activities and what's going to be the effect of that precedent, the complexity of that precedent network going down with these right skewed durations. And Monte Carlo is the only way that we can actually measure the impact of those things occurring. So let's take a quick look at, hopefully I can, there we go. At how we would set something up. So I'm just going to quickly just grab all of this and just going to reset this. So once we bring the schedule in and we can bring it in, you can import it, you can generate it in here. You can import from Microsoft Project, Oracle Primavera, our two main ones. We also have our own calculation. You can generate it in here. However you get it in, the first thing we want to do is run a scheduled diagnostics, which I showed on the, and it will come in and it will tell you which activities, where you should be looking. Again, missing logic is one. We have some that are just not linked to the, we have milestones, and it sort of looks at the summary activities as not having links, so it does come up. High float, but these are probably hard constraints is the one we're looking at, relationship types. We don't want to have too many of those in there. And if you want to look at what's causing that, we can double click. If you double click on this, you can actually start to see this will bring up a description of that particular test. If we look on here, we can see all of the activities that sort of miss some of the tests. If we go to, here's a sort of a high level look at that. If we want to configure the tests, we can bring it up here, and this will say whether you want to read them. This has, you know, float. If you're concerned about that, you can change it so it's configurable. We want to take this out, you can just copy it all, and you can copy it and drop it into Excel, or you can double click on one of those and it'll show you which activity it is. So we want to resolve those. Anything that comes up, especially around hard constraints and missing logic, are the ones that will. And if you do have them in there, if you do have a lot in there, first thing you'll see is we do run a logic check. And if there are problems with the precedent network, logic problems, those links will show up as red on the interface. So once we've done that, we want to assign risks. Now, this one already has risks assigned to it, but if you want to take a look at how we would assign it, we could say a labor risk. We've added that. Now there is a whole bunch of information we can see behind that, but just in terms of doing an assignment, we can go to the drag and drop, and we think, if you think perhaps that these two summary activities are going to be affected by that, we can grab this risk and you drag it across, and we're going to say we're going to go a relative delay. And I'm just going to give it some random values here and say, and we'll calculate. We can go to the risk register. And actually I can see just by how I modeled that that is the most critical risk on the system. So that's one of the outputs. And that's how we do it. We want to look at how all of these risks are assigned to the schedule. We can see it here. So each one of these has a risk, and they've been assigned to a task, and it tells us which task number they are. We want to take a look at that. If we wanted to change some of that, how that's modeled, you can do, it's still going to take some of these outcomes that we'd have to change there, but we could change the type of distribution. This can also be used as a report if you want to go in and have a review about how the risks have been assigned to the project. This is another way to do that. This can all be just printed out or exported to an Excel spreadsheet. But again, if you want to, you can also change the assignments just in here. But all of these risks are assigned to the project, and we get, and actually when we run that analysis right here, the project summary that we're going to get, this is based on risks. So we're seeing the impact. And one thing I didn't know, this is all of our costs are being driven by resource costs in here. So it's all time dependent costs. So we can see that really we're seeing basically that's the deterministic, that's our original project schedule. You can see that here, and these are those risk events occurring that we had, and that's what's causing. So we have these, it's a multimodal or polymodal histogram per cumulative prob that we get a histogram. So we see different distributions. But the one thing we haven't added is uncertainties. Now, uncertainties can be added several ways. They can be imported from your project schedule if you have them in Microsoft Project and you've gone with your team and added low and high estimates. If you haven't and you bring them across, you can manually go in. I don't really recommend this, but if you do have this, you could go in and add them like this, and that would then automatically add that. If you don't assign a statistical distribution to it, it'll actually add behind the scenes. It'll say it's a triangular distribution. The other way that we can do it is we had previously, if we wanted to, we had the set low and high duration, and this is I'm going to say we're going to add it, multiply it on a coefficient, so everything is going to be 0.8 and 1.5, and we're going to add a triangular distribution to it. You can see it. And it's giving it a color because that corresponds with our uncertainty bands. Now, the other thing that you can do, and this is, what we're doing is we're calculating the uncertainty based on coefficients. One of the ways that we do it with uncertainty bands or with those other ones, we sort of we'll characterize what are low, medium, high, critical, can be up to 10 different levels. What do those mean in terms of uncertainty? And this is how we can set it. It's set, I'm just going to add up that one to 1. There we go. You can see, and they're all going to be slightly right skewed. This one, when we critical, has a lot of uncertainty. And if we wanted to assign those based on that, we can quickly go through and we can assign it at the summary level, and it will be inherited down. We can assign those to specific ones. And now what we do is by doing this, we have a schedule that has both uncertainties and risks. And because we've changed the schedule, all of those results get erased because it's no longer valid. The next step that we're going to do is we're going to set up our calculation options. I'm going to have it, again, this is the Monte Carlo simulation, instant Monte Carlo. It's set on. I'll just change that to there. On my parameters, I'm going to turn it up. I'm going to have 1,000. I'll just turn on this convergence so we can see how many will run until it actually converges. And I've set my custom percentile to P80. So P80, normally that value is between P70 and P80. The less risk tolerant you are, the higher we're going to set this number. And I'm going to calculate, and you can see that it's, okay, so it's changed. We can see actually that labor risk has gone down in importance, probably all the different uncertainties and where that labor risk is associated with. So there are uncertainties that are driving that. We go to the result Gantt, project summary. We can look at the cost changes to that, and we can now see that those uncertainties have sort of really affected the results, whereas before we had that large deterministic was over here. Because of those uncertainties, it's the most probable is now shifted over here, and we brought it over this, and here's our P80. So in this case, at a summary level, project summary level, on our cost contingency would be the difference between, this is just right off the bat, but obviously before any optimization comes, is the difference between the current schedule and our high. That's sort of what our risk adjusted margin cost contingency would be. The difference on finish times would be the difference between our current schedule and our high. So here it looks to be that we have about a month. And so if we went to the finish time and looked at that, we could actually see it. P80 is August and deterministic is in July 14th. So we would need about a month of schedule margin, depending, and wherever that you put that, you probably distribute that across the schedule in margin tasks. We wanted to look at where would we put those. You can start to look at the result Gantt, and again, it's going to have that same information here. So we have 2 days if we're looking at. This will give you some idea. You can generate reports on this, but for this activity, there we go. It's 93 days. So at this activity, you probably want to have about schedule margin of around 12 days. You can do the same here, and pull that out of in your reporting. So that's really how we go and run through the process. Import or create the schedule in your project view. You can add resources as this one does, or fixed costs. Import it. We're going to add risks from the risk register, and then we're going to assign 3-point uncertainties. If you don't already have them, you can do them manually and add a distribution type, or you can use the uncertainty bands or the low hawk cost. These are some of the older interfaces that we had from previous versions that are still there. You can use that. We run that, we set our calculation off, and then we calculate. And from that, we're going to pull out how much contingency and margin we should have at a project level, the sensitivity analysis. So if we want to understand which activities are going to have the most effect on cost. So these are our most impactful. We might want to look at finish time. Again, this is basically a little bit of what I call a forensic, but we're looking at the analysis, and these are telling us which activities we need to do. We can actually look at risks as well, and it will drive that if we want to know which risks are driving finish time. So very similar to the risk register, we can do the same thing. We can look at which risks are driving costs the most, and we can see that here. Again, these are our critical risks. Can't really do much about weather, but these are the ones we were doing. Finally, one of my favorite views on that comes out is the crucial task. This is again taking that sensitivity analysis and putting it on your Gantt chart so you can identify it. So as we go through with your team, you run the analysis and you can see which activities you need to focus your project optimization on and monitor during project execution. So with that, I'm going to open it up to questions. Unfortunately, I've got my question pane. Let me just see if I can't get it. There we go. So I've got some questions I'm just going to take a look at. From first one's from Scott. Do you consider residual risk that remains after all mitigations have been performed? Yes. Okay, yes, that's it. So really when we run the Monte Carlo, I didn't show it here, we want to be running it typically in post-mitigated status. So you go in, you can run some scenario analysis, you can do multiple baselines on that, choose a baseline, And once you've got all of your risk handling in place that you want, and you believe it's at that, I mean, that's one of the things is that we're assuming they will work. We're going to run that, and that residual risk is basically uncertain. The risk that you're going to be running that Monte Carlo on is the residual risk for unmitigated risk and uncertainty. So in the case of that, I would, if you have an activity like that, then you know that you're off to a meeting that's at a location and you know they're going to be back. Then that doesn't really make any sense, unless you think there is, like I might, we might convene earlier. But yeah, that's that's a judgment call. Is a PMI PDU code available? No. It's not for our webinar. We're not PMI. We're not a PMI organization. We follow their processes and try to be compliant with them and are compliant with them, but we don't give them for the webinar. I'm not aware of the DECM health metrics in addition to the Fort Pay, not in our software. The issue is we provided what we consider the DCMAs of like the bare minimum that you need to be able to have run a valid schedule risk analysis. There are a lot of other tools on the market with some Microsoft Project or P6. There are add-ins that will run, 50 or so different metrics, and for us, that's just for us and for a lot of our clients, that's a bit of overkill. And those ones that are our clients who are really concerned about schedule quality, not just for risk analysis, but for other issues, tend to have their own, and they can, we have one client that has like 170 different metrics that they measure. So how does the Monte Carlo generate the new Gantt diagram based on the results of the simulation? So what it does is it actually taking, when we run the analysis, and I'll just, I can go to the result Gantt. What that is doing is, if you can, I'm just going to pull this down. What that's doing is, and this is a bit busy, so we're just going to, so this is what it's showing is the original estimate versus and this is our P80. So this is our high, and we can select right here. So it's generating a new alternative Gantt chart based on your high results. And if we wanted to look at that, you can see all of that for particular activities just by right-clicking on that. So that's what's happening there. It's taking with risk, no risk, and deterministic with risks and uncertainties. If you wanted to show where are the risks occurring, you can actually click on one of those, and these risks are color-coded to indicate criticality or ranking in the system. And if they're down, they're threats, and if they're risks, or if they're up, they'd be considered opportunities. And so that's what's happening. Now, if I wanted to see the low results, so this would be our P30. See, even our P30 is getting pushed out past our, and that's really what we see for low and high results, again, is being set here. So this is high, and that's a low. So that's what's happening there. Oh. So we go. How many should you run? I always recommend, I always going to recommend like a minimum of 1,000. Should get you a nice one. Okay. Well, thanks. Scott, I'm just looking at this. Run 1,000. A lot of times what I'm going to just say is that should be standardized across your organization. A lot of times you'll have, it'll be contractual that you'll see in a contract when you do it as part of if you have to go to an ownership group and they'll say you need to run X amount of simulations. And so you can enter that in. Sometimes I've seen like, sometimes up to 5,000. I haven't seen really any that go above that. If you're just doing it for your team internally, 1,000 with the codicil or the condition that if you have high impact, low probability risks, you want to run enough iterations that it will account for those risks. So if you have a risk that has a 2% chance of occurring, that's a really high impact. If you run 100 iterations, on average, it's going to occur about 2 times. And if it has, let's say that high impact has a distribution curve to it. So it has, you've said, well, it's, low impact, high impact, but you really have to think about, okay, if let's say I have 1 or 2 things, you might want to run, put that up maybe 2,000, so it occurs, it occurs 40 times during a simulation, or maybe even higher than that. But you just want to make sure that you account for those risks occurring, get the full impact. If it's a single impact, like so you don't have a distribution, you don't have the impact model as a distribution, but it's like, if this occurs, it's going to cost me $20 million. Then the amount of iterations you're going to run, it'll account for that fairly easily within that 1,000 or so. You'll get that impact. But again, judgment call. If you find that you can go in and do some experimentation and say, well, we ran 1,000, and then when we ran 2,000, we suddenly saw that the cost, our P80 changed significantly. So we need to start, when we have these types of risks, we probably need to make sure that we run a higher number of iterations. And again, yes, the DCMA equals the DCMA. So that's So what we run in there is the minimal requirements that you would see for if you were submitting a schedule to the DCMA, which is the Defense Contract Management Agency, and it's a sort of a standard schedule quality, minimal schedule quality check that you'll see across a lot of different activity. A lot of different industries use it. So I'm just answering. Okay. Yes, DCMA. So Defense Contract Management Agency is the or standard project quality assessment. Oh, I'm just trying to see, Mr. Introduction. Would you consider unmanageable risks that still to consider? I'm just sort of going over some more questions that have come in. Make sure I've got them all. I think that covers everything. If there are no more questions, I'm going to finish the webinar. Ooh. I would use, if I'm going to, Scott, we just have another question. If you have a task that has no uncertainty as to the remaining duration, like a meeting, it will start on a given date and finish on a given date. I would just say I would actually not apply any uncertainty to it all, because we just I wouldn't apply any uncertainty at all, because you know that you're going to a meeting and you'll be back. Yeah, so that's one of those ones that's it's sort of going to have an anchoring on it, unless you think that you might finish a little bit earlier and then be able to, the team will start working. Again, a judgment call. And I've got one, can the software read MS Project? Yes. Software, we're got pretty deep integration. We have an add-in that comes with. Yes, and I've got one from Luis Gomez, who would like to ask a question. Sure, go ahead. If you just want to type it into the questions, I'll be quite happy to answer. So just in case, okay, so just a question on Monte integration with Microsoft Project. We have an add-in actually that will go in with Microsoft Project. If you have Microsoft Project installed, it will install the add-in. Actually allows you to run a simple Monte Carlo simulation in the add-in. If you want to use risk events and have some of the more, and really basic outputs, if you want to take advantage of some of the bigger, and it comes with the software. So they're not separate pieces of software. If you want to do risk events and you want to look at some of that cost analysis or sensitivity analysis, in-depth sensitivity analysis, or use the risk register, then you'd want to import it in, and it's literally you just have to do some mapping to make sure that your columns are mapped up, and we do have some. We do have tutorials online for that. It's very simple to do. You just want to say where your low and high estimates are within the system. You can run it there, or you can click a button and bring it straight over to Microsoft, right into RiskyProject, and set up your model in RiskyProject. Really depends on what works best for your company. If you're using risk events. Task level able to be saved in a Microsoft custom field. Like you can task level able to be. You can save some. We will import up to 20 text fields, I believe. We have that's in the system. So if you have them mapped into a text field in Microsoft Project, and you want to bring that data across for sorting, or you can go here and you can insert that column, but I'm just going to say, if you look here, so there's all these text fields. So if you have some information in a text field, in Microsoft Project that you want to bring across for identification purposes, you can bring it here, and you could just add that to the views. So it would be simple like this. And once you've got it, let me just go down. Let's say it's text 18 that you have it in. It's in there. And once we do that, you'd want to save the column layout. So you don't have to add it every time you bring in the schedule. So now that text field will be part of the default views in RiskyProject if you want to bring in data across from those text fields. Oh. Export from simulate into an MSP. Not exactly. Our simulation results at the task level able to be saved. Oh, I understand. Sorry, I'm completely wrong. So what you would actually do is you could actually save. You could export it back. That's a tough one. You can't actually do it. What we do is we save this as we export it as an XML field. The one thing that you could do if you wanted to, if we look at that, you go to the result Gantt. Let's say we go to the result Gantt. You could copy them and then paste them into the Microsoft Project field. And what you could do is actually make it a little bit easier. Is you could take this and export, and just export the field, the whole view, and with the results into Excel, which make it a little bit easier to cut and paste from Excel into Project. And export as Excel. It will take all of the results, from this view, and just plop it into an Excel. And then from there, you could then move it into Microsoft Project, and you might be able to import it. I'm not a master at Microsoft Project in terms of all the different capabilities it has in terms of bringing in data from Excel, but you could either copy and paste it from Excel, or there might be a way that you can import it through a mapping dialog. I know there is some of that. I know that capability exists. It's slightly outside of what I do on a day-to-day basis. Yes. Okay, an archival purpose. And the other side of that is when you're, I understand what you're saying in terms of being able to run your assessments over time. And that's probably the way my own feeling. I would probably be easier to use the export to Microsoft Project, and then or you can generate, if you wanted to, because this is all the results. What you can is you can export as an XML file if you wanted to create an archive of that. Of course, now I'm not sharing that. You can export an XML file at a certain percentile level. So if you risk adjust, so a lot of people will go in and say, okay, we've done the analysis. I want to go in and re-baseline my project at P50 or mean or some value. And you could actually then export that out as an XML field file, and then import that into Microsoft Project, and then you have that record there. Now I don't know if that would work either. But that would be that's taking, but that is a certain level. So it's exporting out a determined, not a range of values. It's exporting out a certain percentile confidence level as a deterministic schedule. So it's not giving you low or high estimates or low and high results. It's just giving a single value when you export it out as an XML field. Okay, it looks like we are complete. Again, thank you everyone. Thanks for the questions. Hope I was able to clarify. You can always get a hold of me at mtrumper@tabor.com, or if you want to go in on our website, if you have a question, you can use our support to ask questions. Like I said, we are going to be recording this, and it should be back up on our site within 48 hours, depending on how quickly they get it back to us. But thank you very much, and without any more questions, I'm going to close the webinar for now. Thank you very much.